Hi everyone, in this video we'll look at three basic built-in math functions in Python: the round, the absolute, and the power function. Let's start with the round function. You can use the round function to round off long trailing decimal places. The round function takes two parameters. The first parameter is the value you supply for rounding. For example, we can supply a value of 1.23456. And the second parameter controls the number of decimal places you like to round off. So for example, we can supply a value of 2, and let's print this function and execute line 28. Alright, the round function will return 1.23 since we are rounding off to 2 decimal places. If we change 2 to 1 and execute line 28, the round function will return 1.2 since we are only rounding off to 1 decimal place. Now by default, the second parameter is set to none. So if we just supply this round function with a value without the second parameter, it will simply round off to the nearest whole number. So let's execute this this statement. Alright, and we can see that the rounding would round this value to the nearest integer or whole number. Alright. Now this round function can behave strangely when we are rounding off at the value of 0.5. So let's take a look at an example. Say if I want to round off 1.5 to the nearest integer, and if I execute this line 28, I would expect the rounding off to be the value of 2. And this is what we expect from round function, right? Now let's try changing 1.5 to 2.5. Now I would also expect the round off to be quite consistent, and it should round off to the value of 3. So let's execute. Now something strange is happening here. Instead of rounding off to 3, the round function returned 2. Okay, nevertheless, let's try with more examples. Let's try with 3.5 and execute line 28. Now, rounding off 3.5 is consistent to our expectation that rounding off would round to the nearest value of 4. Okay, now let's try 4.5 and see the round off. Now round function in this case round it down to 4 instead of 5. All right. So there is something strange happening here. In computer science, they call this a rounding ties to even strategy. All right. This is where programming languages follow certain international standards in rounding off values. Don't be alarmed when you encounter this peculiarity. We can always change this behavior using other functions from imported libraries. For example, there are functions to explicitly just round up or round down values. Now this is not unique to Python. Other programming languages that follow this standard of rounding off will also display this same behavior. We will not go into depth of rounding ties to even strategy, so that we can focus on the more important programming topics. So for now, don't worry about this behavior. Okay, so let's move on to the next function of absolute. Okay, so absolute will return a positive number regardless of its initial states. For example, if we supply a value of negative 2390 to this function of absolute and execute line 28, you can see that absolute function will return the value as positive. Let's try with another number, say 0.0003 minus 0.0003, and let's execute line 28. You can see that the absolute function will return to us a positive decimal. Okay, now the absolute values or the absolute functions has its own place and use in math and statistics. So it is helpful to have this absolute function around. All right, now let's talk about the next function called the power function. Now this power function is similar to the exponent operators. So if you recall from the last video on some arithmetic operations where we use 2 asterisks to raise a number to a power, it is similar. So the power function will take 3 parameters. All right. The third parameter is an optional parameter. The first parameter is the value we supply, and the second parameter is the power. So if we put 4 and 2, let me just uncomment it, and if we supply 4 and 2 in this power function, we are simply saying that we want to have 4 raised to the power of 2. Okay, so let's execute this line and see the return. It won't be a surprise that it returns to us a value of 16, since 4 to the power of 2 is 16, right? So let's take a look. So the value is 16 as expected. So in other words, it is quite similar to using the exponent operator. So if I use 4 with 2 asterisk 2, the same kind of operations will achieve the value as well. So let's execute both lines, and we can see that the function and the arithmetic operations with the exponent operator returns the same results. All right. Now, let's talk about the power operator or the power function one more time. The third parameter, while it's optional, if you supply it, it actually acts as a modulus operator. So the power function will return a remainder instead. Okay, so if we supply the last parameter with a value of 2, it simply becomes a modulus operator, and so the value returned will be 0. So let's execute this and take a look at the results. Okay, so the value is actually 0. It is almost saying this, all right? It's almost saying using the arithmetic operator, it is almost saying like this: 4 raised to the power of 2 modulo 2. All right, and let's print both lines. Let me just give it a space between each of this character. All right, and let's see if both returns the same value. Okay, so now you can see that this power function is very similar to the arithmetic operators that we have learned from the earlier videos. Okay, that's all I have for you in this video. I will leave the methods of isInteger for you to go through in the last section. All right, so thank you, and I'll see you in the next video.